Hello, my dear bachcho, and welcome back. I know, the board exams are just around the corner, and a chapter called Continuity and Differentiability can look a bit scary, right? But please trust me on this. By the end of this quick explainer, you'll see it's actually one of the easiest topics. Let's make it super simple together. I can almost feel that exam tension building up. But hey, take a nice deep breath. Don't you worry, Beta. We are going to break down all the important bits of this chapter into easy, guaranteed, scoreable points. You ready? Okay, let's dive right in.
So, first things first, before we even look at a single formula, let's just get the main idea. What does it actually mean when we say a function is continuous? Well, the answer is so simple you can figure it out with just a pen and paper.
That's really it. Seriously, we call it the pen test. If you can draw the entire graph of a function without your pen ever leaving the paper, then it's continuous. But if you find there's a break where you have to physically lift your pen and jump to another spot to keep drawing, well, that's a discontinuous function.
Just look at these two graphs, for example. See the one on the left? That lovely smooth curve? You can trace that whole thing with your finger, no problem, without ever lifting it. That's continuous. But now look at the graph on the right. See? You draw the first piece, then you have to lift your pen, jump up, and start drawing the second piece. That little jump, that break in the path, that's what we call a point of discontinuity.
Okay, so the pen test is amazing for understanding the concept, but in your exam, you need to prove it with some maths. But don't you worry, it's not some crazy long formula. It's just a simple three-step checklist. I like to call them the 3 golden rules. For any problem on continuity, this is all you need to do. First, you check the limit of the function as you come towards the point from the left side. We call that the LHL. Then you do the same thing from the right side, the RHL. And finally, the third and most important step, you check if both of those limits are exactly equal to the actual value of the function right at that point. If all 3 of them match up perfectly, the function is continuous. So the whole game is this: the value from the left, the value from the right, and the value right at the point. All 3 must be the same. Think of them as 3 best friends who have to meet at the same spot. If even one of them is somewhere else, the friendship is broken, and the function is discontinuous. Simple. All right, let's put our 3 golden rules to the test. We're going to use them on a question that looks a bit tricky and pops up in exams all the time: the greatest integer function. But you're about to see how simple it becomes when you just apply our rules. So why does the graph of the greatest integer function f of x equals bracket x look like a set of stairs? Just remember what this function does. It always rounds a number down to the closest integer. Let's see how that creates those steps. Take a good look at this graph. See how it's flat for a while, and then poof, it suddenly jumps up to the next level? These jumps, these breaks, they happen at every single integer, at 1, at 2, at 3, and so on. These are the exact points of discontinuity that we're looking for. Let's use our rules on one of these jumps. Let's pick the integer 2. Now, if we approach 2 from the left side with numbers like 1.9 or 1.99, what's the greatest integer? It's 1, right? So our left-hand limit is 1. But if we approach 2 from the right side with numbers like 2.1 or 2.01, the greatest integer is 2. So our right-hand limit is 2. And there we have it. The left-hand limit is 1, and the right-hand limit is 2. Are they equal? No way! Our golden rules have failed the test. And this means the function is discontinuous at x equals 2. In fact, this happens at every single integer. See? Simple, Haina. Okay, now that we're masters of continuity, let's meet its best friend, differentiability. These two ideas are very closely linked, and understanding how they're connected is super important for your exams. So what is this big word, differentiability? In very simple terms, a function is differentiable if its graph is perfectly smooth at that point. That means no sharp corners, no pointy bits, no kinks. If you can zoom in really close and find one single clear slope at that exact point, it's differentiable. Now here is the most important link between these two ideas. This theorem basically says that differentiation is a much stronger condition. If a function is smooth, it must also be connected. So if a function is differentiable, it is 100% guaranteed to also be continuous. This little table makes it crystal clear. Differentiable means the graph is super smooth, which means, of course, it has to be continuous. But a continuous function is not always differentiable.
You know the perfect example? The modulus function, y equals mod x. Its graph is shaped like a V. Now, at x equals 0, there's no break, so it's continuous. But there's a sharp corner, right? A pointy bit. You can't draw a single smooth slope there. So it's not differentiable at that point. Always remember this one-way friendship.
Okay, enough of the theory. You know the best way to build confidence is to actually solve a question. So let's do a typical exam question together, step by step. Ready?
Here it is, a question from your textbook, exercise 5.1. The mission is to check if the function f of x equals 5x minus 3 is continuous at x equals 0. So what do? We use our 3 golden rules. Chalo, let's solve it.
Okay, let's check. Rule number 1, the left-hand limit. As x gets close to 0 from the left, 5x minus 3 becomes 5 times 0 minus 3, which is minus 3. Okay, rule 2, the right-hand limit. Same thing. 5 times 0 minus 3 is minus 3 again. And finally, rule 3, the actual value, f of 0, is also 5 times 0 minus 3, which is minus 3. And look at that, LHL equals RHL equals f of 0. All three are minus 3. So yes, the function is absolutely continuous. Amazing work, you did it.
And you know what? That's pretty much it. Once you know what you're looking for, these problems are actually quite easy. Just remember the simple pen test to understand the idea and the 3 golden rules for your exams. Your confidence for this chapter should be at 100% now.
So I'll leave you with a little challenge. Go through your textbook. Look at all the graphs of functions you already know. Now that you're an expert on the rules of continuity, which ones do you think are secretly discontinuous? Finding them will be great practice. All the very best for your exams, Beta. You are going to do great.